Hey guys, okay, so today we're going to continue with the quadratic formula, and I'm going to show you specific examples of different types that you might see. So the first example we're going to do is whenever our radical is a perfect square, so the answer works out nice and pretty for us. Okay, so that's going to be our first example. So when the answer works out nice and pretty. All right, so the first thing we always want to make sure that we look for is that our equation is set equal to 0, which it is right here. So perfect. I can go ahead and identify my a, my b, and my c value. All right, so I know my a value is the coefficient to x squared, so I look at x squared, I look at the number in front of it. So my a value is a 3. My b value is the coefficient of x, so I find x, I look at the number in front, it's a positive 10. And c is your constant, that's the number that's by itself, which is a negative 8. All right, so now that I know a, b, and c, I can go ahead and plug into my quadratic formula. So I know the quadratic formula is a big fraction, so I'm going to just put a big fraction bar. And it starts with negative b, and I always think of that as the opposite of b. So if my b value is a positive 10, I'm going to start with a negative 10. So negative b plus or minus the square root of, and inside the square root, the first thing says b squared. Well, inside the square root, it's very important that we use parentheses. So the first thing is b squared. So I'm going to take my b value, put it in parentheses, and square it. Then it says minus 4 times our a value times our c value. All right, on the bottom, it says 2 times a. So I'm going to have 2 and times my a value, which is a 3. All right, the next thing I want to do, guys, is inside my radical, I have a lot going on. So I'm going to figure out, I'm going to type just that part that I highlighted into my calculator to see what that will simplify to. So give me just a sec. I'm going to rewrite it as negative 10 plus or minus the square root of, and like I said, I want to simplify the inside of the radicals. So I'm going to figure out what do all these numbers come out to be. So negative 10 plus or minus the square root of, we're about to simplify that. Okay, on the bottom we have 2 times 3, which is 6. All right, so what I'm going to do is I'm going to get my calculator. Guys, you could do this in any calculator, but I'm going to pull up my Inspire just because that's what I already have on my laptop. And I'm typing in, remember, only the part that I highlighted, only the inside. So parentheses are important. So I'm going to have parentheses 10 squared minus 4 times my a, which was 3, times negative 8. Okay, so remember, this is what was on the inside. I'm going to go ahead and click enter. So I know all of that is going to simplify to 196. All right, so now what I want to do is figure out, does the square root of 196 simplify into a whole number? Is it pretty, or is it a decimal? Okay, so what I'm going to do now is I'm going to simplify, and I'm going to type this piece into the calculator because I want to see, does the square root of 196 give me a beautiful whole number? All right, so now what I'm going to do equals negative 10 plus or minus, and on the bottom I have my 6. But what I want to do now is I want to type this in to see, does it give me a whole number? Is that a perfect square? So now I'm going to type in the square root of 196. And I get 14. So the square root of 196 is a beautiful whole number, which makes things easier for us. So I know that's simplified to be a 14. All right, so this plus or minus here means the first time I'm going to, on the numerator, I'm going to add these two numbers before I divide. The second time I'm going to subtract before I divide, okay? So the first time I'm going to take negative 10 plus 14 and divide by 6. The second time I'm going to have negative 10 minus 14 and divide by 6. All right, so let's go ahead and work that out. On this problem, if I have a negative 10 and I add 14, that's going to give me a 4. I know 4 divided by 6 is 2/3. So one of my solutions, it means it's going to touch the x-axis at 2/3. All right, so let's do it over here. So we did it with the plus sign, now let's do it with the minus sign. So if I have a negative 10 and I subtract 14, that's going to give me a negative 24. And divide by 6. Ooh, sorry guys. Well, I know negative 24 divided by 6 is a negative 4. So I have two solutions. One of my solutions is 2/3, one of my solutions is negative 4. So what that means is my parabola will touch the x-axis at 2/3 and at negative 4. So you can write your answer like this. Okay, and that was an example of when our radical turned out to be a pretty number. So this guy right here, the square root of all of this, was actually just the whole number of 14, which works out nice for us. Okay, so on this problem we had two solutions, you see? Solution 1, solution 2. Sometimes that's not always the case. Sometimes we only have one solution, which means our parabola will only touch the x-axis once. Okay, so how would that problem look? All right, so the first thing we always check is our equation set equal to 0? Well, right now it's set equal to negative 9, so I need to fix that before I identify a, b, and c. Well, to make negative 9 equal 0, I had to do the opposite. I add 9 to both sides. What I do on one side of the equal sign, I do on the other. Okay, a negative 9 and a plus 9 cancel, so that's equal to 0 now. All right, on this side I have x squareds, x's, and constants, regular numbers. These are all different, which means they're not like terms. So all I can do is write it as 4x squared plus 12x plus 9. All right, so now that it is equal to 0, I can identify my a, b, and c. So I know my a value is 4. My b value is 12. And my c value is 9. Okay, so now that I know my ABCs, now that I know my A, B, and C value, I can go ahead and plug into my quadratic formula, which is a big old fraction. And that formula starts with negative b, so we think of that as the opposite of our b. So if my b is a positive 12, I want to start with a negative 12. So negative b plus or minus the square root of b squared. So I put my b in parentheses. Minus 4 times the a value times the c value. And on the bottom, I have 2 times the a value. Okay, so from here, we have a lot going on inside the radical, so I want to go ahead and simplify the inside part. All right, so that's going to be on the top, I'm going to have negative 12 plus or minus the square root of, and I'm going to simplify the inside here in a second. On the denominator, I have 2 times 4, which is 8. All right, so let's go type the inside part only to see what that gives me. So that's 12 squared minus 4 times 4 times 9. Oops. So all that stuff on the inside is just simplifies to 0. Okay, now what I want to do is I want to see, can the square root of 0 simplify to a nice pretty number or not? Okay, so on the top I'm going to have negative 12 plus or minus. We're going to go type this into the calculator, the square root of 0, to see if it's pretty. On the denominator we have an 8, so let's go figure out what is the square root of 0. The square root of 0 is 0. Well, 0 is a very pretty number. So the square root of 0 is simplified to 0. All right, so it's simplified nice and pretty for us. We like that. All right, but to find our solutions, I have to do on the numerator with addition. So I'm going to add these numbers before I divide by 8, and then I'm going to subtract before I divide by 8. Okay. So the first time I'm going to take negative 12 and add 0 before I divide by 8. The second time I'm going to subtract 0 before I divide by 8. Okay, so let's do this one first. Negative 12 plus 0 is negative 12. Negative 12 divided by 8 is negative 3 halves, or we know negative 3 halves is the same thing as negative 1.5. So we know one of the solutions is negative 3 halves or negative 1.5, whichever you like better, fraction or decimal, which means I know my parabola will touch the x-axis at negative 1.5. All right, so let's do it over here. Let's do it with the subtraction now. Well, negative 12 subtract 0 is negative 12. And then I divide by 8, and that's going to give me a negative 3 halves, which is the same thing as negative 1.5. Okay, well, I have my one solution, I have my second solution, but if you notice between these two, it's the exact same number. So I don't have two different solutions here. I only have one solution. So you don't have to write it twice. You're only going to write it once. I mean, if you put negative 1.5 comma negative 1.5, I wouldn't count you wrong, but it's the same number. It's only touching the x-axis at negative 1.5. So, for example, here's my x and y axis. My parabola would only touch one time there at negative 1.5. That's what that would look like. All right, so that's an example of if you only have one solution. Okay, sometimes you have no solution, all right? So what would that type of problem look like? Well, I know the first thing we do is we always have to make sure it's set equal to 0, which this is not. So that's going to be my first task, make it equal 0. Okay, well, to make something equal 0, you do the opposite, so it cancels. Well, that's a negative x, so the opposite of that would be a positive x. And I have a positive 3, the opposite of that, it would be a negative 3. So what I do on one side, I have to do the same thing on the other. Okay, positive x and negative x cancels. Positive 3, negative 3 cancels, so that's how this side is now set equal to 0. On the left side, we have x squareds. We have x's and constants. These are all different, which means they're not like terms. So I'm going to write it out as negative x squared plus x minus 3. All right, so now that it's set equal to 0, I can identify my a, b, and c values. So a, I look in front of x squared. I see a negative, which is the same thing as a negative 1. B, I look in front of my x. Well, in front of the x is just a positive, right? But we know that's the same thing as a positive 1. And our c is our constant, the number by itself, which is a negative 3. All right, so now that I have those numbers, I can start with my quadratic formula, which is a big fraction. And it starts with negative b, so I think of that as the opposite of b. The opposite of a positive 1 is a negative 1. Plus or minus the square root of, all right, so b squared, so I'm going to take my 1, in parentheses, square it, minus 4 times the a value times the c value. On the denominator, it's 2 times the a value. Okay, remember from here, have a whole bunch of stuff going on inside the radical. So the first thing I want to do is simplify the inside of the radical. So I'm going to have -1 plus or minus the square root of, and what does all of this simplify to? So I'm going to type that in the calculator in just a sec. On the denominator, 2 times -1 is a -2. All right, so let's go simplify all this stuff. So I'm going to have 1 squared minus 4 times -1 times -3. And it gives me a -11. So all this stuff on the inside simplified to a -11. Okay, so now what I want to do is the square root of -11. Does this simplify to a nice, pretty number? All right. So let's go type in the square root of -11 real quick. And notice what it says. Non-real calculation, okay? In Algebra 1, we can't take these are what you call imaginary numbers, which we won't deal with in Algebra 1. So what we do whenever we're dealing with the quadratic formula, what it means when we get the square root of a negative number, guys, is you can stop your work right there. As soon as you see a negative inside the radical when you're doing the quadratic formula, stop your work. You can't do it, okay? And if you can't do it, what that means is no solution. I can't do it. There is no solution. So what would that look like? Okay, an example of this would be, here's my x and y axis. All right. An example of a quadratic, a parabola that has no solution will look something like this. Notice this parabola never touches the x-axis, and that's why it's no solution. We can't find where it touches the x-axis because it doesn't. So no solution. All right, so that's an example of what it would look like to get a no solution. All right, this is going to be our last example, and this is going to be an example where we're going to have an irrational answer, which means it's not going to work out nice and pretty for us. But that's okay. Math doesn't work out pretty most times, and it doesn't mean you're wrong. It's just the way it is. All right, so how would that look? All right, the first thing we always check for is the equation set equal to 0? Nope. So that's the first task. So to cancel out a -4x, I'm going to add 4x. To cancel out a +2, I'm going to have a -2. What I do on one side, I need to do on the other. Notice I'm going to put my x's under x's and my constants under constants. Oops. Okay, right here we know a negative, oops, I didn't mean to do that. A -4x and a +4x cancel. A +2 and a -2 cancels, so now it's set equal to 0, which is what we were trying to do. Okay, over here we have x squared, so I didn't add or subtract any x squared, so that guy will drop down. Okay, over here I added 4x's, but I had -3x's. So these are like terms, which means I can combine them. -3 plus 4 is a +1, so it's going to give me +1x. And then constants, the regular numbers. I know I'm subtracting 2, but I had a +7, so I can combine these. A +7 subtract 2 is a +5. All right, now that it's set equal to 0, I can identify my a, b, and c values. So a, I look in front of x squared, is -2. My b, I look in front of x, which is a +1. And my c, my constant, is the number by itself, which is a +5. So now that I know my a, b, and c's, I can go ahead and start the quadratic formula, which starts with -b, the opposite of our b. So the opposite of our b is a -1, plus or minus the square root of b squared, so I'm going to put my 1 in parentheses, square it, minus 4 times the a value times the c value. And on the denominator, I have 2 times a, so 2 times the a value. All right, let's simplify. So what I'm going to do is I want to type just the inside of the radical because there's a lot going on in there. So I want to simplify that piece, right? So I'm going to have negative 1 plus or minus the square root of, and I'm going to have to simplify all of this. And on the denominator, 2 times negative 2 is a negative 4. All right, so let's go type all this inside stuff in. So 1 squared minus 4 times negative 2 times 5. So all that stuff on the inside is going to simplify to a 41. So it's the square root of 41. All right, so now I want to see, does the square root of 41 simplify into something nice and pretty for us? All right, so on the top, let's go see, does the square root of 41 simplify into anything pretty? Oops, my bad. The square root of 41. Nope, sure doesn't. It gives me a big, ugly number. Just keeps going, right? All right, so when that happens, this is how you can write your answer. So when it turns out ugly like that, you can write your answer 2 ways, okay? You can leave it in radical form like this, or you can change it to a decimal, and I'll do both, okay? So since it's a big, ugly decimal, I'm going to just leave it as is. But the first time I'm going to use addition, and then the second time I'm going to use subtraction. So on the numerator, I'm going to put negative 1 plus the square root of 41. All over negative 4. Okay, there's a lot of times you can leave your answer written this way, okay? But if you want it as a decimal, I can go ahead and type this into my calculator as well. All right, so I'm going to do negative 1 plus the square root of 41. After I get that, then I'll divide by negative 4. So I had negative 1 plus the square root of 41. After that, I'm going to divide by that negative 4, which is, I'm going to round it to negative 1.35. Negative 1.35. Okay, so this is what it would be exact, and this is rounded. Okay, so we did it with addition, so this time I'm going to do it with subtraction. So now I'm going to take negative 1, and I'm going to subtract the square root of 41 all over negative 4. Okay, so you could probably leave your answer like this, depending on your answer choices, or we can change it into a decimal by typing it in. All right, so this time I'm going to have a negative 1, subtract the square root of 41, after I do that, then I'm going to divide by that negative 4, which gives me, I'm going to round to 1.85. So this one didn't turn out as nice and pretty for us. So this is an example of when it works out like that. So when it's not pretty, you can leave it as a radical. So I could write my answers like this, comma this. Or you can change it into a decimal and round your decimal answer and have this as your solution. It's just written in different ways. And depending on what type of problem you want, it might ask for it written this way, or it might ask it written as a decimal. For now, I'm going to write my solutions just as decimals, okay? So I know it's going to touch the x-axis at negative 1.35, and then again at 1.85. All right, guys. See you later.